Here is a question that I'd like us all to keep in mind as we go through the contents of this video. Are neural networks a type of representation learning system? That's the question. Do keep it in mind. And let's revisit it at the end of this video. Let's now turn our attention to understanding deep learning, which is fast becoming one of the hottest buzzwords out there today. Let's pick up from where we left off. We spoke about how traditional ML based systems still require human experts to tell those systems what features of the data to focus on. And as the ML based system that we are trying to build becomes more and more complex, the role of those feature selection experts becomes more and more important. Representation learning systems, on the other hand, go one step further. In this, the feature selection step is now carried out by an algorithm rather than by a set of human experts. So, representation machine learning based systems, in a sense, figure out by themselves what features in the data need to be paid attention to. This is extremely important as the formats or the feature vectors become harder and harder for human experts to work with. It's relatively easy for a human expert to tell a machine learning based classifier to focus on how a mammal or an animal breathes or how it gives birth. And it's only easy because these are attributes which experts have spent decades studying. But this shifts the burden from the expert to the classifier, because now for the classifier to do its thing, you actually need a live animal. You need an animal where you know how that animal breathes and how it gives birth. Let's say that you only have images or videos of whales or of animals in general, then a representation based ML system is your only bet. The system is going to have to be smart enough to parse those representations of pictures or videos of different animals and use them to decide what features are important. And then, on that basis, come up with the appropriate label. So, representation based learning systems try to figure out by themselves what features are important. And the most common and important and currently popular type of representation learning happens through something known as deep learning. And deep learning itself is a slightly generic term which mostly has come to refer to one specific type of ML system, and that is a neural network. So, again, deep learning systems are those in which algorithms will learn on their own what features really matter. Neural networks are a specific type of deep learning algorithm, the most common and the most popular. TensorFlow is quite versatile, it can do a bunch of stuff, but really, what's making TensorFlow the hottest tool in town is its facility with deep learning and neural networks. And neural networks, in turn, are composed of units, simple building blocks, which are called neurons. We'll get to the details of what exactly a neuron does and how neural networks learn, but here now is a high level, a schematic representation of how a deep learning based binary classifier would work. This would be a complex system which would take in a corpus of images and feed these into different layers. One of the layers would deal with, say, pixels. The layer after that would abstract those pixels or group them and work with edges. Then edges and other features of the image would in turn be passed to yet another layer, which may be recognized as corners, and so on and so forth, until finally we would get a final output layer which deals with object parts. That would then classify, on the basis of all of this, that image as being that of either a fish or a mammal. And that's how a neural network would function as an ML based classifier. Each of these layers consists of building blocks called neurons, which we will get to in a moment. The layers that the programmer deals with, the input layer, which takes in the pixels, and the output layer, which will actually classify the images, these are known as visible layers. The other layers, the ones which lie in between, are hidden, and really, you, as the designer of a neural network, have very little idea what's going on in the neural network as a whole. This is pretty much a black box. And this can be really disconcerting even to experienced folks in the field of machine learning, because in deep learning networks, unlike in other learning mechanisms, the black box, the lack of transparency of the neural network really means that you've just got to trust the model. You don't understand why the model is making a certain prediction. You've just got to hope that it knows what it's doing. This was just a schematic example. In general, a neural network consists of layers Each layer is a set of similar neurons which are similar in their structure. More on that in a moment. The term deep learning actually refers to the fact that this neural network has a bunch of layers arranged in depth. The layers in a neural network are what give the term deep learning its name. As we've said on multiple occasions, the individual layers consist of neurons, and there are complex interconnections between the neurons in each of these layers. In fact, it is possible that we end up with too many interconnections, we end up fitting our training data too well, and we end up having to drop some of the connections. This is known as dropout. I give this as an example of the process and of the challenges in designing neural networks. The challenge here is in creating a good map, a good architecture with all of these layers, making the right choices about the type of neural network, the interconnections between the neurons in those different layers, and so on. For instance, for image processing, you typically use a convolutional neural network. For text processing, you would often use recurrent neural networks. It is actually decisions like these, the type of neural network, the manner in which you will represent pixels, the manner in which you will set up layers to process groups of pixels. The challenges in creating deep learning applications lie in making such choices and architecting and tweaking such choices. And the reason for the popularity of TensorFlow is that such choices are actually very easy. They are abstracted away for you to a very large extent. In any case, coming back to our introduction to neural networks, these are a type of representation learning system. These are a type of deep learning system, the most popular type out there, in fact. Neural networks consist of layers, and each layer consists of individual interconnected neurons. Neural networks really come into their own when the dataset is so large and so complex that not even human experts have a successful track record of finding patterns in them. Let's return to the question we posed at the start of this video. Neural networks are indeed a type of representation learning system. Or to put it a little more precisely, neural networks can be used to build representation learning systems because neural networks can pick up on the features in the data that really matter. If we set up enough neurons with enough complex interconnections, the neural networks will figure out for themselves what features really count, and that is the defining characteristic of a representation learning system.